My name's Adam Wright, and my colleague Vladimir Sporny is joining me. Say hello, Vladimir.
Hello, everyone.
Just a little bit of housekeeping at the beginning. We've scheduled 45 minutes for the webinar. We'll have a presentation about 15 to 18 minutes, and then my colleague Vladimir will do a hands-on demo, and we'll reserve 5 minutes at the end for questions and answers. If you have a question, please type it into the chat box, and we'll answer those at the end of the webinar. So you won't have a chance to actually speak with us, but type in your question. And of course, if you want to do follow-up for a deep dive, we can do that. So also, I need to let you know that this is being recorded, and that's good, so we can share it with you and other partners and customers in the future. So let's move on. And just one last point, Vladimir and I will turn off our video because we find it helps the platform work a lot faster. Yeah. So just a little bit about Whalebone, who we are, what we do. Yeah. So Whalebone was founded in 2016. We focus on the DNS layer. We are a DNS resolver, but with a protective feed. Yeah. We first got traction with telcos by helping the telcos create a product for their customers to bring cybersecurity and to prevent malicious attacks to mobile phone customers. We have telco customers in 40 plus countries, and this is quite significant for our threat intelligence, and I'll explain that later. During our existence, we've won different awards. We've been recognized as a fast-growing company in Central Eastern Europe. Again, we are a European-based company based in the Czech Republic, so we follow different ISO standards. We're required to follow some parts of NIS2. We respect GDPR. We're European-based. So that's about Whalebone. One thing I think is pretty significant, and this will come up during the presentation, is in addition to our success with telcos, we have lots of ISP customers. We also have plenty of enterprise and government customers, including our first national system that covers one whole country. But one quite significant milestone at Whalebone was when we won the DNS for EU project from the European Commission. And this project had 3 key goals. Number 1, to create DNS independence for Europe, so people wouldn't rely on DNS resolvers outside of the US or in the US. To encourage the exchange of cyber threat intelligence between different country certs. And the third was to work with countries to adapt a protective DNS service for the public sector. And it's moved quite well. Yeah. So that's enough about Whalebone, but just to be sure that we understand or have a common understanding about DNS. So DNS is the domain name system. It was a protocol adapted with TCP/IP in the mid-1980s. And when it was created, together with TCP/IP, the two things that let the internet really scale, there was no idea about how it could be used for malicious activity. That wasn't a thing in the mid-80s. Yeah, nobody even had internet really. So it's a key component of how the internet works, but it's remained unprotected. Yeah, and we, in our opinion, and I think a lot of people share it with us, that all malicious activity at some point touches the DNS layer. Yeah. And that protecting your DNS layer should be your first line of defense. We don't take the place of a firewall or an antivirus, but since DNS is the first point of contact for malicious activity, it should be the first point to block. And then if something does go through, because it does, then your firewall can catch it. If it goes beyond the firewall, the endpoint can catch it. But you need to layer your security. And the DNS layer is what we call a beyond parameter, and it protects your environment before anything even touches it. Yeah. Some quotes from different organizations. So the Cybersecurity Infrastructure Security Agency, they recommend that a protective DNS service is really key to ensure high availability and to protect your environment. The European Commission recommends that member states should encourage the development and use of a public and secure European DNS resolver service. It's part of the DNS for EU project, and we're helping to make that happen. A quote from a NSA director in the US who is an advisor for cyber and emerging technology, quoting that DNS can reduce the ability of almost 92% of all malware attacks, both command and control or in dropping malware onto a given network. So, and we've got lots of other resources that encourage the use of a protective DNS. One of the best, if you really want to have a good look, is to go to ncsc.co.uk, the National Cybersecurity Center of the United Kingdom. So ncsc.co.uk, and one of their key services is protective DNS for the public sector, and they have a lot of good information about how protective DNS can help you. So here's some customers, some names. One of these we'll talk about today, Panasonic, but we also have a lot of, we've got banks, we've got other manufacturing, and insurance companies, telcos, of course, ISPs. They all use our resolver, yeah, with the protective feed. So this was about how we helped Panasonic and how we help manufacturing in general. So let's get a little more specific about Panasonic. So this is a direct quote from one of their IT specialists in Slovakia, Lubomir Gavenda, and he said that Whalebone Immunity has already proved that it can stop new threats. It blocked malicious websites the moment our users tried to reach them. From our experience, it would take at least another day for a traditional firewall to add these malicious domains to their threat database. We'll talk a little bit more about that when we explain how we do our threat intelligence. Yeah. So these are the problems Panasonic were facing. Zero-day attacks. So firewalls were slow to list and push out new malicious domains for blocking. Employees out of the network. Remember COVID? We all remember COVID. A lot of people learned to work at home, and it's here to stay. So people work from home, they travel, and they were dependent on the resolver service of their ISP or a public Wi-Fi, say in an airport, which definitely isn't secure or safe. And their firewalls and endpoints wasn't enough for them anymore. The growing number of threats led to more damage from malicious attacks. That's why they were looking to find something to harden their cybersecurity beyond just the firewall and endpoint, the antivirus. So this is how we solved it. This is how Whalebone Immunity solved it for Panasonic. First of all, for the zero-day attacks. So Whalebone, and I'll explain this a little bit more when we go through how we do our threat intelligence. Zero-day attacks, usually coming from domain-generated algorithms. These are so big in quantity that it's really hard to keep them in an active database. Yeah, they come and drop off unbelievable speeds. Yeah, so in addition to some classic ways of doing our threat intelligence, we also use AI and neural networks that help us to identify anomalies within the DNS layer or within the DNS traffic. So we look at the DNS traffic as a whole, not just individual DNS requests. And when we start to detect something malicious, say more text in the text field, yeah, which wasn't coming before, then we flag it and we start blocking. Yeah, and it happens a lot faster than you would see with a traditional firewall that from time to time is updating their databases. Employees out of the network. Yeah, we provide an endpoint client that directs DNS queries to your immunity resolver. So when your employees are out of office, home, traveling, anytime they're getting on the internet or doing any background services, it'll connect to your resolver using your company's policies and using our great threat intelligence to keep them safe. So no more dirty ISP connections at home, no more dirty Wi-Fi at the airport. And Panasonic said firewalls and endpoints weren't enough. So what they did is they used a protective DNS service, Immunity, which, as I said earlier, extends security beyond the perimeter. So even before these things hit their firewall, we're already protecting it. Yeah. And there's even more things we do. So DNS tunneling and domain-generated algorithms. Protective DNS services are really good to stop these compared to, say, a firewall. So sometimes firewalls will just look at the individual DNS records, not as a whole. We look at it as a whole. As I mentioned, With domain-generated algorithms, DJAs, these are so much volume that you cannot keep them in an active database. The only way to identify and work with these is, like I said, use AI with some neural networks and try to detect anomalies and then flag those domains and stop them. With the DNS tunneling, this is very specific to DNS. So malware might be dropped, it opens up a tunnel, and they start extracting information, passwords, data, all that good stuff, yeah? Phishing, we stop phishing attacks. So there's always someone that's going to click in your organization. Someone always clicks, and the attacks get more and more sophisticated. And it's hard for your employees to realize that it's a malicious attack. And we stop it. So the minute they click on that phishing attack, our resolver says, oh, it's a malicious domain. We block it. They can't connect. You're good. Homograph attacks, these happen less and less, but they still happen. Basically, any of the domain registers, a homograph attack is when you use two alphabet sets in a domain. So like google.com, one of the O's might be from a Greek alphabet, one of the O's might be from the Latin alphabet. Your user won't be able to see the difference. But in fact, they are different domains. This shouldn't happen anymore, but some domain registers still allow this and they don't catch it. So we stop homograph attacks, which are almost impossible for an end user to see the difference between google.com and Google with a Greek O, Latin O.com. Additional service we provide is called leaked passwords and sensitive information. So we have identity protection, where we associate your domain with your instance of Whalebone Immunity, and we capture, or we scan different parts of the web, or dark web, if you want to call it that, different sites that sell data, passwords, logins. And if we see anything that's associated with your domain, we present that to you in the interface, and you can act on it. Just real quick, so people don't think how a malicious attack works. There's lots of phases during it, and that's why a DNS service is really good, because all these different steps are touching the DNS layer. Yeah, so it might be a domain we don't know is malicious. It hasn't come onto any lists. Nobody knows it's malicious. So they might be able to do, say, the first 2 or 3 steps. They might do some reconnaissance, harvest some emails, addresses, conference information, whatever. They might be able to start weaponizing it. Yeah. To prevent that, we have this leaked data and password monitoring. Yeah. So we might be able to capture it really early. Yeah. Sometimes it can get beyond that. So you could get to a delivery where through an email or some web page or some other third-party software, they might actually be able to drop the malware. Yeah. And start to use exploitation, install the malware, and that kind of thing. In that phase, exploitation phase, the protective DNS service, it can block the delivery by denying access to that malicious website. It can block communication needed to install the malware, and it can notify the administrators what devices have been targeted, so they can do triage and look at the exact devices to prevent the further spread of malware. And then you get some actionable items. If they get all the way to 6 or 7, they've done really good. But even in point 6 or 7, using a protective DNS service, we can still limit the damage of a malicious attack. Yeah, by blocking any communication needed to gain the objectives, like locking. Like maybe they want to lock a database. Maybe they've started a command and control, or they've started DNS tunneling, and we block it then. So it could be that we might miss it in an early stage, but we catch it before it actually starts to run the damage, or very early on when the damage starts, yeah, which firewalls don't always do. Yeah? So one last bit, I want to make sure that there's some other things we can do. Sometimes you have some national laws that need to be blocked. This is usually for ISPs. There's also ISO requirements, maybe. And then there's NIS2. NIS2 doesn't specifically identify protective DNS services outside of some critical infrastructure, but it does talk about it. And we can imagine that moving forward, the use of a protective DNS service, protected resolvers, will become a standard requirement for most countries or most governments. Yeah, so we can comply to that as well. If you have some specific questions on that, you can put it in the chat box, or we can do a follow-up call to tell you how we do that. Vlad will show you a little bit during the demo how we can help a company comply with any national laws for blocking. Yeah. So I'm going to just finish up a few more slides, and then I'm going to give over to Vlad so he can show you a demo. But this is the magic sauce: is who does the best threat intelligence? That's what it's about. The best blocking rates with the lowest amount of false positives. That's what you need to spend your money on. Yeah. So in our mind, the industry standard, which anybody who's offering protective DNS service or the firewalls include some extension for DNS, they usually use some public or community data sourcing from different websites and things, some threat intelligence sharing. They might have their own threat intelligence, which they develop from their endpoint, the devices they cover, the firewalls. They might have some other partnerships, or abuse operators that exchange things, and they might have their own in-house research with security experts. Now, we do all of that. Whalebone, that's just what we consider the basics. But in addition to that, with the DNS for EU project, which is bringing together all the certs in a common exchange within the MISP platform that we manage, a certain part of the MISP platform, and the EU certs are now exchanging information more and more freely through that. And it was a big challenge. A lot of them weren't even ready to use the platform or to exchange information. We use that. We ingest that into our threat intelligence engine. And then with telcos, we talk about endpoint. Endpoint's a great place to develop your threat intelligence, and find malicious sites. Now, if you look at some organizations that take it from just the enterprise section, like maybe an antivirus or firewall, the segments, even though they're geographically very spread, their user base is pretty static. Adults that are working, maybe in different sectors and different things. But with us, since we're really big among telcos, basically and geographically quite spread, our end users are anything from the CEO of a Fortune 500 to a 10-year-old kid on TikTok. So it gives us a very nice broad range of data that we can analyze, run statistics across, and find new malicious domains before they're even published. That's a really big differentiator for Whalebone, is that we focus on it, that we have such a good base with the telco sector. And of course, we do some other things. We have our own internal research. We work with some local universities and their research teams, the Whalebone virtual analyst, Whalebone tunnel block, inputs from our customers. They can report a malicious domain via the web interface that we can capture, DGA sonar to capture these domain-generated algorithms, and then a lot of local regional threat intelligence, research of brands and sectors, domain context analysis, domain behavior analysis. So that's why sometimes if you put us head-to-head against a product from a whole different region, say the US or North America, compared with us, we might be doing better on blocking malicious domains that are more specific to Europe or regions of Europe. So that's our threat intelligence. We've got some numbers behind to prove how we did real well against Allo, Cian, Akamai, also against companies like Cisco Umbrella and Fortinet. So we have no problem to go head-to-head to show that our blocking's higher and that our false positives are lower. Additionally, there's some other integrations we can do for enterprise sector, like integrating into your SIEM log. We've got some APIs. You can use some syslog exports, things like that. But if you can always put a question in the box, and Vlad can answer that during the demo. So I think that's probably enough. I've spoken more than plenty. Just the key takeaways. Just remember, we offer a DNS resolver with a protective feed in it. We're a layer above your firewall in your endpoint. We're beyond parameter protection. Our threat intelligence is top notch because of, as I showed you, we get lots of info from all the certs across Europe, and our endpoint base are mobile phones across the globe with a really wide range of users, from the CEO to the 10-year-old on TikTok. And that gives us great data to find malicious domains before they're put onto any block lists. I'm going to turn the time over to my colleague, Vlad. He's going to open up the user interface, and he's going to show you exactly how the product looks and works, how easy it is to use, what kind of information you can get from it, and then we'll finish up with some questions and answers. Over to you, Vlad.
Thank you, Adam, for introduction. I would like to start with explaining two different types of deployments, but we can use on-premises and also cloud deployment. But usually for the enterprises and especially someone like Panasonic, we really advise to use on-premise variant, because we deploy the resolver as a first thing in a way of the DNS query that gives you options to really see in-depth overview of the DNS traffic. So each device communicates directly with the resolver. Also, it's hosted on your network, your managed device, or your let's say virtualization platform. And there's also really great latency. So we say that usually the installation can take about an hour with some introduction to the customer. So let's do it even quicker. I'm going to start with creating new resolver. I specify the name for the resolver, and I can see that Portal generates this one-line command, which I can now paste to the prepared machine. I will change the screen here. Yeah, cool. Yeah, so I can paste it to the machine. Let's wait for the installation. And now I will quickly jump back to the portal itself until the installation is finished. Yeah, so let's jump back. And how does it work? Yeah, each resolver, as Adam described previously, is equipped with a database of threads, and it consists of around 20 million different domains. And each domain goes through the one big tunnel of threat intelligence. And at the start, it comes from different sources. The URL has some different complexity. It's visited differently than other domains. But at the end, each domain gets a score from 0 to 100. And it's a score of confidentiality. That means the higher the score is, we have higher confidence that the domain is malicious. And that's like basically holy grail of the setting of the security policies. So we can set up security policy based on different types of blocking. So firstly, the first part of security policies are these two thresholds that specifies how strict the security policy will be. Usually for peacemaker customers or ISPs, we set up this block careful listing, but for enterprises, we advise to go a little bit stricter to block every domain that has scored above 60. Everything that has scored between 40 and 60 will be audited, and you can view it in the portal. Also, for if you have your own feed, or you want to explicitly deny something, there's always option to add your own deny or allow list. Yeah, so for this example, I prepared just the deny list for TikTok. Adam also talked about regulatory restrictions. So in case you want to block domains that your law requires, you can, by 2 clicks, import all the feeds that are specified in the laws. That's really important because usually this is provided by your ISP on the DNS level. But if you take the DNS to your own hands and you provide a resolver for the company, you are now also you need to also block these domains. Last part is the content filtering. We have around 17 categories and split it into 4 main ones. So for this example, for this exact security policy, I can, for example, add tracking, peer-to-peer, and DOH content filter. We can also create different security policies, and that's really important because in networks that are more complex, we have several types of users and, for example, machines. Yeah? So, for example, in case of manufacturing, we have one big company full of employees. There are also some IoT or OT machines. We have some visitors. So we can assign different policies for different subnets. Yeah, so let's create a second policy as an example. Yeah, so for example, we will create policy for machines. This policy can be much stricter than the one for the employees. So we can move the thresholds a bit lower. We can, for example, audit everything, and or we can block everything and just follow domains that we know that the machines communicate with. We can also enable content filter for the policy. So let's save it. Also, for cases when there is something blocked and the page should be displayed, it's usually a case of phishing. Some other products display just an X domain, or some server fail error message. But Whalebone shows you a blocking page that could be completely edited. It's completely white labeled. So when the user visits the page, he's informed that, hey, this page is malicious. You're trying to access the phishing page. And he knows that he's safe. And it's not some kind of network error or some misconfiguration. You can have different blocking pages and also assign them to different security policies. So let's go back to the resolvers. We'll see that the resolver is almost installed. And last thing for the simple setup is that we will set up, we will host the blocking page directly on resolver. That gives us option to set up different blocking pages, not just the one that's default hosted on our cloud. Yeah, so that's first thing we will set up. And the second thing is that we can set up the policy assignment. So we will set up different policies for different subnets. So we created a default policy with default blocking page, and we have another policy for the machines. And we know that all the machines are hosted on this subnet, for example. Yeah, and for this subnet, we will apply this security policy. With we can even put there a different blocking page, but basically we don't care what machines see. Hopefully, they also don't care. So that's the basic configuration. We saw that the resolver is installed. So right now we can point some traffic to the resolver. I will run some stress tests from my command line to show you some legitimate traffic. Yeah, so I'm running a test, and right now we might see already that there will be some spike. Let's go to see the dashboards. Here we have 3 different dashboards. One for threats. That's for all the blocked and audited domains based on a score. we have DNS traffic, that's a general overview of the DNS data. And in case of the content filter being applied, we can also display the content filtered data. Data retention for the data is 90 days, so you can go 3 months to the past, and it gives you an option to really perform a deep investigation of even historical events. Each of the dashboards they have filtering options, so we can, for example, filter the data based on the type of action. We can filter. We now start to see some generated data here. We can also filter by the category. So, for example, let's go and see a malware, and for each of the domains, we can filter also based on a level 2 domain and from based on a client IP. So we can see that this is my IP right now. I'm generating some traffic, and this gives us really option to see what are different users doing inside the network. This is also a case for the DNS traffic. We see that the dashboards are really responsive. We can go deeply investigate the traffic. If you want to export the data, you have several options. Adam talked about the syslog. I will show you how the integration works in a minute. Here, you can also export the data into CSV. So about the integrations quickly, the syslog is pretty simple. Here under the resolver, just go to the advanced configuration, and here you can set up the syslog destination, set up host, port, and the type of data. You can choose from content filter, passive DNS, which is DNS traffic, and also the threads, which are the most important. Also, there's option to consume some telemetric data from the resolvers. With other integrations, we have integration with Active Directory or any other authoritative server. So if you want to see also the host names being attached to the logs for all of the data you see in the portal, you just turn on this toggle, specify where you have your authoritative name servers. If you have 2, if you have 3, it doesn't matter. And for each query, the resolver does a PTR query and checks if it gets host name, and if yes, it sticks it to the log itself. With the cloud resolvers option, it's easier even than to deploy on-prem. You just specify your public IP, you specify the policy, you specify the blocking page, and you save it to resolvers. All the policies are then propagated to all of the cloud resolvers we have around the globe. And once this is done, you will also see data being blocked and logged in the portal. We have also alerting. Adam talked about the homograph attacks and about the DGAs. So, for example, if we specify where to send the alerts, this is just for testing purposes, but you can consume the alerts to Slack or via some webhooks, or again, you can consume it as a syslog. But you can create different alerts for different scenarios based on different templates. So, for example, as Adam said about the homograph attack, we can set up a homograph attack alert based on domain we specify. So Panasonic.com, and if we set up this alert and someone uses the resolver and visits some domain that's even one character different than the Panasonic.com, you will get alerted as a network administrator. You can also set up different alerts, for example, for some increases of data in the network. You can set up alerts on also resolver statistics or connections. Last two parts of the product that are somehow side of it are the identity protection, which is the protection of the identity. You can set up your domain pretty easily. If you set up here, you try to add your domain here, it will create a verification string, and when you copy the string and add it as a TXT record on a place where your DNS records are hosted, after a while it gets verified and data leaks will be displayed. Data leaks that are connected to your registered domain. So for our purposes, we can see that we have Minister of Wales, the VP, and for each individual leak, we can see the leaked information or all the data that comes with the leak. And we can see what is the affected community identity and what's also the possible threat. And it can range from account accesses to some impersonations, or it can be also something really different. Also, you see which leak is connected, or to which leak this individual leak belongs. We have the data for last 20 years for major leaks, and this really also gives you a really great overview of how the employees work and behave. Yeah, so for some customers, I really see that they have some leaks from 2024. They don't have some strict password policies, so that's really a red flag for them, and the administrators can push them to, for example, changing the passwords. And the last thing is the home office security, which is featured for to provide off-net protection for the mobile devices. The assignment of the policies is pretty simple, close to the same as assigning the policies to different subnets. Yeah, so I can create a device group, I can assign a policy, I can set up the blocking page, I can even add some exceptions, and with the installation, I can go push it via, for example, MDM, or for smaller deployments, it can easily be activated just through this QR code. And once you scan it in the app, it will be connected as my testing phone here, and also you can see that it blocks the incident and also blocks the data. So you can secure easily clients that travel quite often or that are just working from home. And you can see that the data is right now being blocked. Yeah, and that's basically it. We are pretty on time, I think, Adam. And is there anything you would like to add?
Yeah, sure. Thank you, Vlad. Appreciate the demo. Yeah, it looks like we do have one question here in the chat box. It came to us a different way. Now, just to be clear, is it mandatory to have a local resolver, Vlad, or can it just be up in the cloud as well?
It can be up in the cloud. Usually, when we have some first meetings with the customers, we discuss what are their needs and what will be the best deployment scenarios. And usually, for larger networks, we advise if they don't want to put the resolvers deep in their network, we can deploy their own, let's say, cloud. Yeah, so we will deploy 2 resolvers on a public IPs, and they will just forward the whole DNS traffic from their authoritatives to their designated cloud resolvers.
And if I understood right, the advantage to a local resolver may be some latency, maybe, but also I have more visibility with the local resolver. Yes. What's the difference concerning visibility between the cloud resolver and cloud with local resolver hybrid?
Exactly. As you said, if we deploy it on premise and as a first thing in the path, each individual device connects to the resolver or queries against the resolver. So we see different each individual IPs or even host names if you integrate. Yeah. In case you use the cloud or hybrid, let's say, you will see just 1, 2, 3, maybe 4 different IP addresses, and the whole network is netted behind. Yeah. That's one of the biggest pros of using the on-premise variant. Because with the cloud, you can say that, hey, I have a CNC infected machine in the network. You can maybe say how many of them. You can do some estimate if it's 1, 2, or 5, but you don't know which one is it. Yeah. If you deploy locally, you will directly see that this machine is trying to connect to the CNC server. I would like to. Do we have any other questions?
Yeah. There's another one. Everybody always asks about an idea of how the licensing and the costs look. Our licensing is based on the number of users, and it's a yearly subscription. So it's a price per user times the number of users, or times the number of years you want to have the service. And the pricing plus minus, it's about the price of a cup of coffee per user per month. Of course, it depends where you buy your coffee. There's a wide range of coffee. But what we try to say is, by comparing it to the cost of a cup of coffee per user per month, it's very cost efficient. Yeah, for what you get and the high level of threat intelligence that you get and what you pay for it, you'll find it probably the most cost efficient cybersecurity tool you can use, protective DNS. More cost efficient than firewalls and more cost efficient than endpoint or antivirus. Go ahead, Vlad. You wanted to say something?
Also with the local deployment, this is usually not the case of the enterprises, more like telcos and ISPs, but the on-premise deployment saves you some bandwidth. Yeah. Usually, the malware infection starts with phishing campaigns. Yeah. So the user goes to phishing page, then he is redirected somewhere, he downloads the malware, so that's another secondary data being transferred. The malware is installed, then it starts to connect somewhere, and it's really how the cycle works. And if we block the initial access to just the phishing page, yeah, we save so many data being transferred. Yeah. So that's really also a good thing to mention.
Okay. Well, we're just coming up on the 45 minutes. We appreciate you joining, your time. We look forward to getting in touch with you. Feel free to reach out to Whalebone. On our public web pages, we also have a info request or a demo request form that you can fill out, and we'll get in touch with you. You can set up a deep dive demo, talk about exactly your requirements for your environment, and potentially even start up a demo or a test or a proof of concept within your environment, so you can see yourself how well protective DNS hardens your security, your cybersecurity, and in addition to your firewall and your endpoint. So again, thanks for the time, Vlad. Thanks for everybody joining, and we look forward to speaking to you soon. Have a good one. Bye.
Thank you. Bye.